I used my KP184 electronic load for the discharge test. The electronic load was set to battery mode with remote sense, and the end voltage was set to 9.2 volts according to the user manual. And 5 hours later, the results showed 101.8 amp hour recorded, which is over the quoted capacity by about 2%. Feels very reasonable. And now for the moment that I was waiting for the most, a teardown of this battery so we can check out the build quality. I noticed this really nice double-walled construction with an O-ring inserted here between the two walls, and the top cover edge comes in to press on that O-ring to make a perfect seal. The next thing I notice is very short, thick wiring for the output terminals. This looks like silicone insulated wire. On these black ones, there's 2 of them, and I see 8 AWG rating on them. On top, we notice the big BMS board and the optional Bluetooth module, which I have on this particular model. That's very smart and efficient from a manufacturing point of view. Again, we see foam padding to keep it firmly in place, and a general clean construction. On the electrical connection side, it looks really nice. We notice the voltage sensing wires for the individual cells, then heavy solid jumper links for the high current, and they're not soldered, they're not screwed in. It looks like there's welding, but I haven't seen this type of welding before. It looks perfect and high quality. So if I would have to sum this teardown, I would say all the critical electrical connections are nicely done, including welding on the battery terminals themselves, and really nice thick silicone wiring for the main output terminals.